Hi, this is Module 3B, Scientific Notation. So in scientific notation, the reason that we come across this topic is because often we are exposed to some very large or very small numbers. So here's a good example that some concentrations of drugs may be very low, so a very, very small number, or you might have the numbers of incidences of a disease that have a very large number. And so we then can express these numbers in a more compressed format or more clearly using something called scientific notation. One thing that we want to make note is that when we are expressing numbers in scientific notation, we want to maintain the number of significant digits in the number. So we will continue to do that throughout the examples in this lesson. Okay, so in essence, scientific notation is a shorthand method for writing large or small numbers. And now this is the key part of scientific notation, that it is expressed as the product, meaning two things being multiplied. So the product of a number between 1 and 10. So the first part will be a number between 1 and 10, and that's called the coefficient, times some power of 10. So let's look at this first example. 355 can be expressed as, well, let's think about that. 355 is in the hundreds. So 3.55 times 100 is the same thing as 355. So we can go both ways. And I can then turn that 3.55, that can stay the same, and then the 10 at the 100 can be expressed as 10 to the power 2. So now this number, 355, has been turned into scientific notation. It's not a terribly large number, but you'll see why as we go through really large numbers where it comes in more handy to express it in scientific notation. And let's make a quick check. This was 3 significant figures, and this is also, we always look at the coefficient, that it is also in the same amount of significant digits. Let's look at a different example where we are now going to take a number that is currently in scientific notation and change it to what's called standard notation. So that's just basically expanding out the 6.21 times 10 to the 5. So if you want to think of 6.21 as your coefficient, 10 to the 5 is 100,000. In other words, 5 zeros. And so really what you're doing is you're multiplying 6.21 by 100,000. So your decimal place will move over that many zeros. Sometimes I just look at it like this. If I've got 6.21, I'll just go 1, 2, 3, 4, 5, and I'll add in my zeros. So I'm kind of just doing the same thing, but you know, it's however your brain operates. Okay, so now we're actually going to take numbers and turn them into scientific notation. So let's say I had this number, 3,500,000,000. Just want to make sure I have the right number of zeros. 1, 2, 3, 1, 2, 3. Nope, I needed another set. Another zero there for my last set. So let's say I have that number, 3,500,000,000, and I want to turn it into scientific notation. So let's look at what the steps tell us to do. Well, we write down the number, but include the decimal point. So notice there that we've put in this decimal place. Because after every whole number, if you don't see a decimal place, then in any whole number, the decimal place is understood at the end of the number. We are going to place an arrow then after the first non-zero digit. So just so it's really clear, it's right in there between the 3 and the 5. And then we will count the number of digits from the arrow to the decimal point. I actually go like this. I move my decimal and I go I physically go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sometimes I write my number out really nicely spaced out so that I can physically see the number of places it's moving. So 9 decimal places. In other words, look at how our answer ends up looking. 3.5, 3.9 times 10 to the power of 9. So the exponent for the power of 10 will be the same as the number of places from the arrow to the original decimal point that you counted, or from the decimal point to the arrow. Both mean the same thing. All right, so you go ahead then, please, and practice a couple of questions, turn them into scientific notation, and check in on the filled in answers. And one thing I'm just going to go back really quickly and make a note of is, I didn't do this check here. This was 2 sig figs, and this answer was also 2 sig figs. So make sure to keep those. You don't need to put in extra zeros, for instance, in practice question 2 when you're doing your coefficient. All right, now what if I want to turn a really small number into scientific notation? So the idea is fairly similar. We still want to write down the number including the decimal point. Well, this one already has our decimal point. We place an arrow after the first non-zero digit. So there's my arrow right between the 5 and the 6. I will do the same thing again, count the number of digits from the arrow to the decimal point. Or as I was doing earlier, I'm going to physically think about how that decimal place is going to move. 1, 2, 2 places. And so now our result ends up being 5.6 times 10 to the, now this is the difference between large numbers and small numbers. You want to make sure that you've got a -2. You're turning that smaller number into scientific notation, and so that has a negative exponent. And anytime you want to do a check to make sure that you did this correctly, you could certainly put this into your calculator and make sure that you get this back. Okay, so just a little summary, the exponent will be the same as the negative number of places from the arrow to the original decimal point. And go ahead and practice those 3 and check in with the filled in notes. All right, and we already did turning from scientific notation to standard notation, so I won't do this one again, but you can certainly look at this example for yourself. Let's look a little bit and also go ahead, please, and practice those 2 questions. Let's look at scientific notation and significant digits, just so we're making sure that we're keeping track of our sig figs again. So remember, you count the number of significant digits in the coefficient, and the power of 10 component, we don't look at the significant digits for that part. So here's an example. The density of diamond is 3.5 grams per centimeters cubed, and it has a volume of 29 centimeters cubed. Determine the mass of the diamond, and we're given the mass formula. So let's start filling in. But before I do that, I want to keep track of something. I want to check in on my sig figs. So this has 2 significant figures, and so does this. So I already know that I want my answer to have 2 significant figures. And this is also because it's a multiplication question. So let's fill in. Density is 3.5 grams per centimeter cubed times the volume, which is 29 centimeters cubed. And what's going to happen is your centimeter cubed, imagine this had been, I'll just write it out like, so that it's really clear. I'm going to put it like this, grams per centimeter cubed. Notice what happens with this centimeter cubed on the bottom with this one on top, and that's why your mass unit comes out to grams. So when I work this out in my calculator, I get 101.5 grams. Now I only want 2 significant figures in my final answer. So I will look at the second significant figure and then look to the right of it. The 1 does not bump the 0, but I know this answer is in the hundreds, so I need 100 grams as my answer. And I could also put this into scientific notation. So once again, remember, you place a decimal at the end and then move it in as many places till you get a number between 1 and 10. So this would be, as a final answer in scientific notation, 1.0 times 10 to the 2 grams. And so 2 sig figs in my final answer. That's 2 sig figs 1.0 for the coefficient. Okay, let's look at this one last concept, which is multiplying and dividing numbers in scientific notation. So that is where we are going to apply properties of exponents. So I'll do this one example with you using the steps provided here, but then I'm going to show you something, a neat button on your calculator that's going to let you do it. So when this is saying to multiply or divide the coefficients, depending on what it's being asked to do, and then apply the product quotient property for exponents. So this question's asking us to multiply. So we will multiply the coefficients, so 1.2 times 3.65 times 10 to the 3 times 10 to the 5. So when I do 1.20 times 3.65 in my calculator, I get 4.38. But then think about what is happening when you have the same base and you're multiplying. What do you do with the exponents? Remember your exponent rule. You're going to add the exponents. So this ends up being 10 to the 8. Now let's look at that same question on our calculator. And so this is where I'm going to highlight this button, because my sharp button has this EE button. And I want you to see how it works on my calculator. So I'm just bringing up my calculator, and you might have a different calculator. Try to see if you can find that exponent button. Actually, I'm sorry, I want to retract something. It's not EE, it's this EXP button. It's right above the 7. So not sure if you can see. If you've got a sharp, then you can see that as well. Okay, so let's do this same question. 1.20, I'm going to press EXP. Notice when I press EXP, a little times 10 pops up in the calculator. So 1.20, I don't need to type in the times 10 because that's already now been put into the calculator by pressing the EXP button. But I do need to put the exponent. So 1.2 times 10 to the 3 times, my next number was 3.65. I'm going to press EXP again, and I need to give it its exponent times 10 to the 5. I'm going to hit equal, and you get 438 million. Now, that number is not in scientific notation, but I could certainly put it into scientific notation by, again, applying the rules where I move the decimal over to land between the 4 and the 3, and then I end up getting 4.38 times 10 to the 8, just like we did in the example when we did it by hand. So both methods work. I find the EXP button really handy. Just make sure don't press times 10 and then EXP, because otherwise you're duplicating a second 10 and you don't need it.